Right, Bismillah. Okay. Bismillah. Okay, folks, welcome back to another lesson. Today we're going to be looking at EDEXCEL GCSE Mathematics A paper. In my class here, paper 1 on calculator, syllabus code 1MAO/1H. We intend to go through this whole paper today. It will be in multiple videos and we'll try to join them together on YouTube using YouTube editor. So let's get started with any further delay. Okay, this is a non-calculator paper. Here's some formulas for you at the front. Answer all questions. Right, okay, something is right there. Alright, here we go. Folks, is that nice and clear? Can we all see that? Okay, I'm just going to double check on our recording device to make sure that's... Okay, 1.793. Okay, alright, this one now. Okay, here we go. Right, so let me have this check. Right, question number 1. Given that this is a question based on place value, given that 1793 times by 185 is equal to 331705, write down the value of this. So we need to look at the original question. So Afira, we have 1793 in the original one. What is it in the question? It's become 1.793. So if you made the original value how many times smaller? We made the original value 1,000, we made it divided by 1,000 times smaller. So if you look at our original answer, so 1793 times by 185, that number has become this number. So what happens to the answer? The change that we made, Umar, in the question by making that number 1,000 times smaller is mirrored in the answer. It follows through. So our final answer is 331.705. Whenever you do multiplication calculation, if you do a change on one part, that part is mirrored in the answer. But are you happy with that? Yeah. Next question, 331705, which is that number there. And we normally would divide it by 185 using the original values. So this number divided by this number would normally give you. Are we happy with that, folks? That's the original, using the original calculation. Now, so Mr. Ramiz, this second value here that we're dividing by, it was originally 185, has now become 1.85. So they made this original value 100 times smaller. Now, be careful here. When we are dividing, Hamza, and the numbers on the bottom that we're going to be dividing by, when we change that, is the change the same in the answer or is it the opposite? It is the opposite in the answer. So if we divide this bottom number by 100, we make the answer 100 times bigger. Okay, if you divide by a smaller number, the answer gets bigger. So it works in the inverse way. So we now will have a new answer of 17930. 0 is our new answer. Okay, folks, are we happy with that? Please quickly copy that down into your sheet so I can move on to the next question. Done? Okay. Okay, right. Just focus on the next question. Okay, right, that's lovely, that size is good. Okay, folks, next question. Mr. Mason asked 240 year 11 students what they want to do next year. 15% of the students want to go to college, 3/4 of the students want to stay at school, the rest of the students do not know. Okay, work out the number of students who do not know. First of all, let's make everything the same in terms of, we're talking about percentages and fractions. So little Hamza over here, 3/4, how much percent is that? 75. Excellent. 75%, Ifra, add the 15% gives us a total of so far, the running total so far will give us what? 90%, mashallah, thank you for that. Okay, 90%. And a total percentage, when you do a percentage question, Ramiz, the total percentage for the question will be? Out of 100. So we already have a staff 90% covered. It's out of 100. So we have to do now 100 minus 90. So that will give us 10%. You can talk. That will give us 10%. So the rest of the students do not know. 10% of 240. Now 10% of 240, I don't want anybody to shout the answer. 10% of 240 is one of the most nicest questions in examination, because to work out 10% we're working at 1/10. So 240 to work out 1/10 we just divide it by 10. So 10% in terms of numbers will be equal to 24 students. Done. Okay folks, you should be copying these questions then as I go through, because I only want to rub it off and I want to quickly move on to the next question. I've got a whole exam paper to do. Okay, Hamza, are we okay over here this side here? Are you happy with the method? Make sure you copy all the method down, because this will be the basis of your revision. So when we do your homework, you know it's supposed to be this way. Come on. Next question. Okay, right, here we go. That's it, that's fine. What question is this?
Question 3.
Okay, question, take it back up. Right, yeah. Question number 3, stop there, stop there. Down. Pause. Question number 3. Here are the weights of the babies in kilograms. How many babies do we have in the questions, Mia?
16.
16 babies. So we have 16 babies. Show this information in an ordered stem and leaf diagram. So 2.4 kilograms is our key. Here we go. So staff, this is what I was telling you earlier. So 2.4. So this line here, when you use the line, 2.4 kilograms. Okay. So when we're going to put 2 and a 4, that's going to represent 2.4 kilograms. That's our key. Are we happy with that, Saba? Good. Okay, now I'm going to copy this up here a bit because.
Shall I read this?
No. It's fine. It's okay. We just improvise a bit. So how many lines we have? 1, 2 lines?
3. Yeah, that's it.
One more?
That's it.
That's it. Okay. Right. Let's have a look at the numbers, folks. Now we have to do an ordered stem and leaf. So the numbers must be in order. So we got 2 point something, a 3 point something, and 4 point something. Is that right?
Yeah.
So Mr. Umar, 2 point something, 3 point something, and 4 point somethings. Yeah. So the number that. Yeah. So let's have a look at the 2 point numbers. So we have 2.4. We have 2.7, 2.8. If I miss something out, folks, please point out to me. Is that it for 2 points?
Yeah.
Okay, so that's right down. So we have 4, 7, and
8.
So these ones are done now. Okay. Are you happy with that stuff? Now, next one, look at the 3 point something numbers. So we have 3.5, 3.8, 3.8, 3.3, 3.0, 3.7, 3.3. Is that it, folks?
Yeah.
Yeah.
Right. So, which is the first one then?
0.
3.0. Next?
3.
How many 3's do we have?
2.
2.
2.
Okay, what's next? 3.5.
5.
And then?
7.
Okay, 7 and then 2 8's, yeah?
Yeah.
Okay, folks, look carefully how I'm spreading out the numbers. Do not put the numbers, start squashing them, keep the numbers in line with the numbers above it. So if you, okay, happy with that?
Yeah.
Alright, Mr. Saf, are you copying the stuff down? Because you're relaxing at the back.
No, she.
The exam paper was just here, what do you do there?
You copy on it.
Okay, what are we supposed to be doing today? Subhanallah. Okay, folks, right, let's move on to the next question. Alright.
You forgot the 4.
You got 4.
Okay, one more question. We have 4. So we have 4.4, 4.2, 4.5, 4.1, 4.4, and 4. Did we do the 3.7?
Yeah.
Yeah.
Right, okay, right. Let's go. 4 point, what's next, folks?
1.
1, and then?
1.
And then another one?
2.
2.
And then 2?
4.
4?
4.
4?
5.
5. So 4.1, 4.1, 4. Where's 4.2?
There at the bottom.
4.2, and then we had 4.4, 4.4, 4.5 done.
Yeah.
Is that all of them?
Yeah.
Okay, let's just double check that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 values all done. Are we happy with that, folks? That's how simple a stem and leaf diagram is. Let's get on to the next question. Right. These questions are nice and These questions are a gift. Expand. Okay, expand doesn't mean start getting fat. It means multiply them out. Okay, so the outside number multiplied by inside number, 3 times by 2 is 6. And then little Hamza over here, should have a big Hamza as well. Hamza, young man, 3 times by plus 2, sorry, 3 times by plus t. Excellent. But say 3 plus 3t. Remember folks, we're doing 3 times by plus t. So 3 times by plus t is plus 3t. Okay, next question, Samia. 3x is being multiplied by 2x, that will give us
6x squared.
lovely, because x times by x is x squared. Rotaba, 3x times by plus 5 is equal to?
Plus 15x.
Okay, lovely, I like that. Plus 15x. Remember the plus comes not from here, but comes from the answer. So 3x times by plus 5. Okay, are you happy with that? Okay. Expand and simplify. This one has an extra word. So we're expanding and simplifying. So let's have Ifra. We have the first 2 brackets, m plus 3 times by m plus 10. So Ifra, we start at the m and what we do?
Times it by the other m.
Times it by the other m. So m times by m is equal to?
M squared.
M squared. Then do m times by plus 10.
Plus 10m.
Plus 10m. Excellent. Okay, let's move now to okay, Afira. We have now plus 3 times by
M.
plus 3 times by m will give us
3m.
plus 3m. Excellent. Next we have plus 3 times by plus 10. Remember, we're looking at the signs. Look at the signs, folks. Plus 3 times by plus 10. You must think about the signs.
Plus 30.
That gives us plus 30. Excellent. Thank you very much. Now, we move on to the next part. Mr. Umar at the back. Young man. We need to simplify it.
M squared.
And the only part that simplify, Umar, is these parts. M squared doesn't simplify because there's no the m squared term. Removes the plus 30 doesn't simplify because there's no the plus, no the number. So plus 10m and plus 3m gives us plus 13m. Excellent. Okay, was there any problem with these questions?
No.
Basic algebra, folks. That's good. Okay, folks, Smir, can you feed me the next question, please? Bring it on. Okay, Ramiz, keep an eye on this. We've got 6 minutes left. If you hear beep beep, that means it's end of video. Okay, listen out for that noise, otherwise we're going to end up talking and miss that. Okay, next question. Right. Write 525 as a product of its prime factors, question number 5. Okay, now some of you use this tree technique, is that right? Like a tree, branches and stuff. Okay, if you want to use the tree diagram, carry on with that, but that's not the technique I use. Let's make it put some more drink. Okay. Put some more drink first. She's out of drink. She needs lubricating. Okay, 525. She needs some drink. We're going to start dividing it now by prime numbers. Okay, our first prime number, Saf is? What's the first prime number? 2. Well done, excellent. And the next prime number is?
3.
And the next one is?
5.
Excellent. Well, Master, you already know the prime numbers. 2, 3, 5, 7, not 9,
11, 13.
Okay, but mostly we'll be using these kind of ones. So 525, Mr. Hamza. Which one of those should be divided by that we know definitely will work? Your definitely work will be 5. So we start dividing by prime numbers. So 525 divided by 5. I feel it's thirsty as well. So 5 into 5 is 1. 5 into 2 is
05.
okay, 105.
Divide by
Are we happy if you divide by 5 again?
Yeah.
Okay, so 5 into 10 now goes
21.
29.
and 21 won't divide by 5, you have to divide it by
7.
okay, we divide it by 3 to give us 7.
7.
And then we divide 7 by 7 to give us
1.
1. So we can say now 525 is equal to, I'm going to put them in numerical order. Numerical order, 3 times by 5 times by 5. Okay, now Ramiz, can you simplify that for me please? Ramiz, Mami?
3 times 5 squared times 7.
Okay folks, are we happy with that? If you're missing the end folks, you must say you missed that question out or you missed that bit out. So you want to make sure that this is all correct. Okay folks, are we happy with that?
Yeah.
Okay, come on Smith, next question please. And this one Smith, you'll have to make this more, it's actually on the page. little bit smaller, a little bit more smaller. Come on, Smith, quickly.
It's flashing. I don't
Where?
think it's working.
That's flashing on the bottom.
Yeah.
That's normal, Smith. You just need to get the mask onto the. So you need to get the mask so it comes onto here, Smith. No, you're on this screen. It says when it's just there. It is. Can you keep the mouse on that one page? Because it comes on the page, goes onto the screen. Quickly make it small. That's a stop there. Question number 6. Sorry about that, folks. Question number 6. Ed has 4 cards. There's a number on each card. 12, 6, 15, question mark. The mean of the 4 numbers on Ed's card is 10. What they've done here, they've given you the answer. They want you to go back and work out the question. This is called a reverse mean question. Right, so let's have a look. So, Rutaba, if you want to work out the mean, what do we normally do?
You add them all together.
And divide it by?
How many there are.
And that gives you the answer, which is in this case is?
4.
10. Thank you. Okay. Get some excellent answers today. Right. Right, we have 12, add 6, add 15. 12 add 6 will give us 18. 18 add 15, the same as say 15 add 15. Add 3, which is 33. Okay, this is drawing on me.
7.
Okay, 33, add a number, divided by 4 is 10. You need to work this number out. So opposite divide by 4 is? Times by 4. So we say 33, add the mysterious number is equal to 40. It's all part of our solving. So we can see now quite clearly, Mr. Umar, the number should be 7. Plus 33 add 7 is 40. So our missing number is equal to 7. Okay, right, are you happy with that, folks? Reverse mean question. Mean is add them up, divided by how many they are. Right, Samir, keep the mass, don't let go of this. Okay, done?
Yeah.
If you drink too much of that, you have to go to the WC. Okay. Translate shape P. Yes, we don't do this. Translate shape P by the vector 5 minus 2. Here's our shape. So when we do a translate means move it. Rotate means turn it. Reflect means flick it. And enlarge means make it bigger. Translate means move it. So 5 minus 2. Okay, Mr. Ramiz. That's the vector for translation. What does it mean? Explain to the class quickly.
It means you go 5 spaces to the right.
5 to the right. And then?
2 down.
So this is how much you got in the positive extraction. Okay, so we need to finish in the video, yes?
Yeah, 50 seconds.
Okay, let's just quickly move this question. 5 minus 2, let's grab a corner. 1, 2, 3, 4, 5. And then 1 and 2. So that point goes over here. What we're going to do now is reconstruct the shape from there. So draw it back again.
So that pin is annoying.
Okay, right, and that will give us the answer over here. Okay, folks, I think that's the end of this particular video. And please join us in the next part of the question. Right, here we go. Okay, folks, welcome back. This is the second part of this video. We are on the EDEXCEL paper. Right, what question number is me? I can't see the question number on there.
That's
Number 8.
Question number 8. Okay, question number 8. Right.
7B.
7B. I said.
Oh, thank you.
Do you want
Right, it goes describe fully the single transformation that maps shape A onto shape B. Let me tell you a common response by students. Transformation. You can't use the word transformation in the answer. Transformation means generally. So you've got to give the specific type of transformation. I.e. is it translation, enlargement, is it rotation or reflection. So let's have a look at the shape here. Now folks, what does this shape look like? What does it look like is happening to you at the moment? It looks like a...
Be flipped.
No, it's not a flip.
1A rotation.
It looks like a rotation. To check that it's rotation, what we need to do is find 2 sets of corresponding points. So Umar,
1.
so I'm going to put this point here, and its corresponding point is
That one there.
that one there. Okay, and I'm going to do another corresponding other point here.
Yeah.
So for example, here, where's this one?
There, right there. Number 3, 1.
Right there, yeah?
No, it's not up there. Up
It's the
there.
next to
Okay.
the blue one.
Up
This
there.
one over here?
Yeah. That one.
Okay, good, well done. somebody's awake. Right, let's start drawing some lines across. Okay, now, the easiest one to do, okay, let's join on. Let's join the corresponding points. So folks, leave that on yours as well, please. Okay. Next one colour. Join up the two blue points. So you're finding where those points cross. Just a little bit more accurately. I don't know, slowly. Okay. Right, sorry about that squeaking bit there, folks. Okay, right. We have a point of intersection here. So the technique was, we have the red point, this point corresponds to the same point on the shape there, corresponding points, and the same for that corner and this corner. So you use two different colors, where the lines cross will give you the center of rotation for the shape. Okay, now what can we say about the angle of rotation? So the first thing we're going to say, I'm going to write down here, I'm writing mine up here. We're going to say this shape is a rotation. That's the transformation. So rotation, how many degrees?
180.
180. Now when we say 180, do we need to say clockwise and anti-clockwise? No. Okay, and then where is it about? So Ifra, at the back, please, quickly. What's the center of rotation? What is it?
1.
Is it 0, 1? Okay. Coordinates 0, 1. Okay. 1 is just the y coordinate. That will give you 3 marks. Okay. Right, good. Ready for the next question, folks?
Yes.
Mia, can you give my next question ready?
Cover.
Yeah, that's it. Can you make it bigger, Mia, please? Come on. A bit more bigger. That's it. Can you make it a little bit more bigger? No, that's it, Mia. That's up there. Okay, question number 8. Margaret has some goats. The goats produce an average total of 21.7 litres of milk per day for 280 days. Are we on the right question, folks? On the right page?
Yeah.
Margaret sold the milk in half a litre bottles. Work out an estimate. It's estimate and not guesstimate. Okay, we're not guessing. We're not making things up. For the total number of bottles that Margaret will be able to fill with the milk. You must show clearly how you got your estimate. So, first of all, Mr. Umar, if you look at this number here, 21.7, the highest place value is the 2, which is in the, which column is in? The 10th column. So if you ran 21.7 to the nearest tens, I'll call that my nice chunky number. That gives us a chunky number which looks like 20. Right, Rutaba, what is the place value, what's the highest place value for this number?
300.
It's in the hundreds. So if you round off 280 to the nearest hundreds, we will get, what do we get?
300.
300. Another nice chunky number. Nice numbers are easy to deal with. Okay? Now we have half a litre. We look at that number first. Is this number needing to be, does it need to be rounded or is it already chunky already? And the answer is already chunky. It's a nice, lovely, half is a nice number to deal with. Okay? So, let's have a look how we're going to work out the total number of bottles. So we have that many days, 300. That's become 20 litres. So 300 days, producing approximately 20 litres per day. Okay, and we're going to put those into half litre bottles. So we're going to divide it by half. Half, you're not going to round off. That's exactly where we need to be anyway. Okay, if I keep an eye on that, is that okay? It's recording? Good. Okay, now 300 times by 20. Let's have Mr. Hamza. The easy way to do is 3 times by 2, which is 6. And then how many zeros do we add?
2.
1, 2 and
3.
3. Okay. Now, 6,000 divided by half, Ramiz, be quiet because you don't have to do before. Right, 6,000 divided by a half. Rutalba, 6,000 divided by a half. When you divide by half, what do we do? When you divide by a half, times by 2.
Times by 2.
So the answer is
12,000.
12,000 litres. Okay, folks, one quick way to think about this. When you got 6,000 divided by half, we're not dividing it by 2. Most students' response in the examination is 6,000 divided by half is 3,000. And that's wrong. This is saying 6,000 divided into halves. How many half pieces would you have? If you had 6,000 cakes and you divided them into half pieces, you would have how many pieces? 12,000. Okay? Or if you want to look at mathematically, when you divide by a fraction, you turn the fraction upside down. So 6,000 divided by a half becomes 6,000 times by 2 over 1. That gets flipped, divided comes times. And that becomes 12,000. For those of you who want to be mathematical. Okay, are we happy with that question, folks?
Yeah.
Let's move on to the next question. Okay, Fira, keep an eye on the, make sure it's not gone blank or start making funny noises, the camera. Okay, right, make it a bit more bigger, Smith, a little bit more bigger. That's beautiful. Question number 9. Matt and Dan cycle around a cycle track. Each lap Matt cycle takes him 50 seconds. Each lap Dan cycle takes him 80 seconds. Dan and Matt start cycling at the same time at the start line. Work out how many laps they will have each have cycled when they are next at the start line. So this is looking for the LCM.
Oh.
Okay, Mr. Ramesh, start finding me the 50 times table.
So 50, 100, 150.
Okay, that's that one there, yeah? Start that one. Who's the 81?
80,
80.
60, 240.
Okay, 240, carry on going.
320.
320.
400.
Okay, now, when you look at the big one here, 400, well, we know that's not in the 50 times tables.
No.
Okay, does that look like it's in 50 times table?
Yep.
Yeah.
400. 8 and 5.
Okay, now we need to think, for 80 to get to 400, how many times do you have to go around the cycle track? 1, 2, 3, 4, 5. Okay, and for the 50 times table to get to 400, we need to go how many times?
6.
8. Okay. Because 50 times by 8 is 400. 8 laps and 5 laps. So in the answer, which one's 50? So Matt will take him.
8 laps.
And this one will be
Dan.
And that's the answer to that question. Okay, so we'll consider the LCM. How many of these before they start matching? That's when the first match. Right. I feel you happy with that?
Yeah.
Is it making sense? You copied it down?
Yeah.
Good. Right, here we go. Take it up a bit. Right. The diagram shows a garden in the shape of a rectangle. So we have the length is 4 plus 3x and the width is x plus 6 meters. The perimeter of the garden is 32 meters. Now, let's quickly have a definition of perimeter. Perimeter is what? Perimeter is the distance around the shape, yeah? So, how many of these do we have?
2.
And how many of these do we have?
2.
So, it's going to be 2 of these and 2 of
them.
So the perimeter is these two lengths here, Omar. Yeah. These two lengths that you can see, add them up and double it because that's replicated here and that one's replicated here. That's what the 2 indicates. Now, it's told that the perimeter of the garden is 32. So I'm going to rub this out for the moment. You can do on yours on the next line and put 32 in there. Because work out the value of x. Right, what do we do now, Hamza? What do we do to get these x's out from them? So we got 4 plus 3x plus x plus 6 times by 2 equals 32. We want to work out the x's, so we can first of all, there's a time by 2 here. What's the opposite time by 2? So 32 divided by 2 will give us
40.
Okay, now that we move the multiplier by 2 over, the brackets have evaporated. That's why one minute is gone. Now we need to simplify this. Okay. So Samia, we have 4, add 6.
10.
Mashallah, that's good. Okay. Right, next with our we have 3 plus 3x and plus x. That gives us plus 3x and plus x will give us
4x.
plus 4x. Excellent, lovely. Let's just copy down. Right, Mr. Ramiz. Now I need to work out the value of x. X has been timed by 4. That's called the first action. It's been added by 10. That's called the
second.
So the opposite, move the last action first. Opposite add 10 is
minus 10.
So 16 minus 10 is 6. So we have left over plus 4x now. Okay. Right, bismillah, okay folks. Sorry about that little gap in the video. Bit of battery failure there. I'm exhausted as we... Right, here we go. 6 equals plus 4x. Right, we had Mr. Umar explain to us. So we need to move the multiply by 4 over. Opposite time by 4 is? Divide by 4. This is the point here. At this point, students start panicking. Okay, they start getting the jillibities.
Okay.
Now, 6 divided by 4 is, if you work it out, so 6 divided by 4 is 1, remainder 2. So that is the same remains as
1.5.
Okay folks, if you get 1.5 in the examination, it's not wrong. You don't need to jump out the window or run out the hall. Okay, so nothing. 1.5 is a properly acceptable answer. We do maths, we get decimal answers, fractional answers, negative decimal answers. So don't get worried if you get a decimal answer thinking I've done it wrong. That's all done. So x has a value of 1.5. We first of all formed the equation, we rearranged it, we solved it, and we're done. Okay. Are we happy with that, folks? We copied it all down. Mr. Saf, are you copying these things down? You look in a very relaxed mode, sitting at the back, they're just sitting there. It's like you're sitting in the Bahamas or in the Bay. Okay, can we make sure that we're actually copying these model answers down? Okay. Okay, right, here we go. Right, Debbie drove from junction 12 to junction 13 on a motorway. That's where she started, that's where she's finished. He goes there. Ian also drove from junction 12 to junction 13 on the same motorway. He drove at average speed of 66 kilometers per hour. Okay, now. Alright. How much time did she do that? So, distance is 30 kilometers. Okay, now, what I want you to do with the ruler, I want you to extend that line. Let's try to work out what the speed was over half an hour. Okay, hang on a second. That's not 20. Is that exactly 20? That's 20 here, isn't it?
Yeah.
Yeah, okay, because mine's just a bit fuzzy, isn't it? Okay, folks, can you please extend your line for me, please? Accurately from the original line. Okay, that's my original line being extended. Now, if Ian drove at average speed of 66 kilometers in 1 hour, okay. Now, what we need to do, first of all, we need to work out how fast she was traveling. So, folks, can you tell me on your graph here, what is the value that this corresponds to? On your graph, it's not too accurate on this particular graph over here. On your graphs, folks, when you extend that line, when you get to 30 minutes,
37.
38.
okay,
38.
38.
37. 38.
Right, let me have a quick look myself. On that, we got 37.
I got 37.
37?
Yeah.
Yeah, 37. 37 is good. Okay, if you extend this line, we hit 37. Three squares on top,
Yeah.
folks, 37?
Yeah.
Right. So according to this particular graph here, she is traveling at 37 kilometers per half an hour. So how fast is that then per hour? How fast is that?
74
So she is traveling at 74 kilometers per
hour.
hour. And that is the lady Debbie. So Debbie is traveling at 74 kilometers an hour and Mr. Ian is traveling at 66 kilometers an hour. So in half an hour, how far will you go in half an hour?
33.
33. So in half an hour we'll go 33. So 31, 32.
Debbie's faster, that means.
So we can see by using both techniques. There's Ian's. Because Ian's graph is below hers, that shows that Debbie is traveling at a faster speed. Because she has to reach here. So this person reaches there first. So Debbie is
What?
traveling faster. She is traveling at 74 kilometers an hour compared to Ian at 66 kilometers an hour. Done. Two ways of doing it. Okay, so we can work out her speed over the whole hour by extending the line, thinking what speed she's traveling, and then we work out his speed as well, and we can see that his line is below, so she gets there first. That's her speed. Done. Remember, she's doing 37 kilometers per half an hour. That the lady Debbie, that means in an hour she's doing 74. So this was Debbie. Okay, has everybody got that down?
Done, nearly.
Smith, don't move forward yet.
Oh.
Yeah.
Okay, done.
Okay, done. What about
Before you done.
okay.
Yeah, she's done.
Okay. Done? On this side, folks? Yeah.
You have to reduce it that much to get the whole page on.
Wow, can hardly see that, huh? Okay, what we're going to do is on the side, over here. So y is equal to, was it half?
Half x plus 5.
Plus 5. Okay, on the grid, draw the graph of that from values of minus 2 to 4. Okay, so we do minus 2, 0 and 4. Okay, right. So I want you to make it as big as you can. And I want to see these two parts in the whole thing. Get rid of that. Quickly.
I must do it.
Move the mouse, because you holding this. It's me over here. That's it. It's me for later. Okay, okay. And then start something. Now bring it all up. Okay, you need to make it a bit smaller. A bit more smaller. That's lovely. That's lovely. Beautiful. Okay, folks, when it says you want you to do from minus 2 to 4, they haven't given you a table, have they?
No.
This means that you've got to cover those two values between them and that. So you don't need to do every single value. How many values are we going to do now?
3.
3. How many do we need to do?
2.
But we can do one extra just to make sure that we haven't made a mistake. Okay, so here we go, folks. That's the function y equals half x plus 5. So we're going to have now half time by minus 2 add 5. So half time by minus 2 is minus 1. Minus 1 add 5 is?
6.
Minus 1 add 5 is?
Plus 4.
Okay, plus 4. Okay, half time by nothing is? Nothing. Okay, and then we add 5. Mashallah, we got some really bright students here today, mashallah.
Thank you.
Okay. Awake students. We got half time by 4 is 2. Okay, don't rush all at once answers, yeah? Half time by 4 is 2. 2 add the 5 is?
7.
MashaAllah, you mentioned it right? Excellent. Ooh. Right, folks. So, Mr. Hamza, we're going to plot which values? These pairs of values. This is going to be my x value, and that's going to be my y value. This is my coordinates. Okay, folks, let's start plotting. Can you read them out to me first? Minus 2 is? Minus 2 is? 4. So we've got minus 2 along the x and up by 4. That's my first coordinate there, minus 2, 4. Mr. Ramiz, read the second coordinates to me.
0, 5.
0, 5. So 0 along the x coordinate and then up by
5.
Up by 5. Excellent, lovely. Next point, let's have a Afira.
What?
4
4.
and
7.
so we go across by 4 and up by
7.
7. Okay, now if we haven't made a mistake in the graph, we should get a straight line. If you don't get a straight line, that means there's a mistake somewhere. Go back and correct it. Okay, folks, get your rulers and try to draw a straight line. Hamza, are you with me? Can you see it, yeah? Know what you're doing? Lovely, Mr. Hamza. So this is y is equal to half x plus 5. Done. Everybody managed to do that in the earlier test?
Yeah.
Yes? No? Oh God. Oh gee. Right, couldn't get there. Right. And copied it. Pratapa, you with us?
Yeah, do you have to do that thing?
Table.
Yeah,
That's what the call is.
because I did it in my head and it was right.
Okay, that's well, you want to show the examiner that you do some calculations, isn't it?
Okay.
Or at least show 2 values.
Okay.
Right, Spade, can you read this next question, please? Okay, this next question I can't do it on the board because obviously the size we're going to use the visualizer now. So folks, just bear with me the moment while I quickly switch over to the visualizer. Okay, and let me try to do over here, inshallah. Put the lights on. Okay. Mr. Ramiz, can I just have yours off you, please?
My exam paper.
Yes, please. Miss somebody's.
So can you turn the light off? Okay.
Okay, right. Ramiz, can you pass me the factor and stuff and thing? Okay, can you hit the light, please? Ben, oh, there. Okay, right. I may need to increase the lights here. Is that a bit better or?
A bit too much.
Is that better? Okay, right now folks, I want to enlarge it for you guys over here watching it. Okay, is that nice and big now? Can you see that?
Yeah.
Okay, let's get cracking. Let me see the ruler there. Okay, because here is the map, the position of ship S is marked here. Scale is 1 centimeter represents 100 meters. Point C is on the coast over here. Ship must not sail closer than 500 meters to point C. The ship sails on a bearing of 037. So we got two things, we got a distance and a bearing. So let's first of all find out, will the ship sail closer than 500? You must explain your answer. Right. Okay folks, can you all get your compasses? Now, if you got 500 meters, how many centimeters is that then?
5. It's 5.
Okay folks, if you got 500 meters here and the scale is 1 centimeter to 500, that means we have to do 500 divided by 100, that gives you 5 centimeter. So what we need to do now, okay, follow me on the board above please folks. Can you measure 5 centimeters?
So down the ruler.
Okay. Can somebody borrow a ruler please?
I got one.
Okay, good. Right. So my compass is set to 5 centimeters now. I'm going to do a... Okay, well it was set to 5 centimeters until it flopped. Let's try that again. So, yeah.
Yeah.
Can you get my master one?
Yeah. It's in the drawer.
I think so. Folks, just give me one moment while I change to my master compass. This one's a bit loose.
This one's a bit tight.
Okay, right, here comes the master of disaster. Right, let's try this. Sorry about that folks, let's just try that again. So we're going to set it to 5 centimeters. Let's just hope this one doesn't flop. Okay, this is 5 centimeters now folks, so I'm going to do now. Inshallah, we're going to do a nice little arc. Okay folks, can you all repeat that please? Can you follow what I'm doing here on the... Just double check that folks, double check it. Okay, now that one is a little bit out. Okay. Let's try that once more. Okay folks, alright. There's a mark here. Just make sure we got that. This compass is a little bit tightening. Okay, right. So can you make sure okay, right. I'm happy with that one now. Okay folks, sorry about that previous attempt, but just that's the nature of this kind of question. Now, we know now the distance from here to there is going to be 500 meters in real life. Yeah? So that here is 5 centimeters, which represents 500 meters. Now, it says we need to do bearing of 0.37, is that right? Now 0.37, all bearings start from north, and we go in which direction? Clockwise. So I'll put the cross over here, the T, on the X, get the 0 line nicely balanced on the 0, and we're going to come around by, was it 30? 7, which is right about here. Okay. So 0, 10, 20, 30, 37 over here. So my 37 is approximately here. So what I'm going to do now, I'm going to draw a line along the 37. Right. Will the ship sail closer than 500 meters? The answer is
Yes.
yes.
I don't know.
You must explain the answer. Yes, the ship will enter the 500 meter radius from C. So that's S, that's C. You can just call this point E. From C at point C, point E. Okay. Okay, folks, we are back live. Yes. Okay. Right. That's lovely. Thank you. Okay. Right. That's lovely. Nice and big. Question number 14. Represent this inequality on the number line. N is greater than -2. So we use an empty circle, meaning that's not part of the solution. So it's going to be everything to this side for the moment. Okay. So here, n is greater than -2, but n must also be less than or equal to 3. Because it's equal to, it must be a solid black. Okay. So it's going to be a number more than -2, but less than 3. So what happens is, these two parts will join together. And that's our solution. Done. Solve the inequality. Ifra, how do we solve the inequality? The way we solve it, like any double-sided linear equation, we treat the inequality sign as though it was an equal sign for the moment. Okay, can you just check that the image is straight? Are we okay? Good. Okay, now, just a answer. Whenever you solve the double-sided equations, okay, we always start with the smaller x value first. So we start at the 6x, we move the 6x towards the 8x. So 6x goes from the left to the, right to the left. So plus 6x becomes
-6x.
and if you move the x's to the left, the numbers must move to the
Right.
So -3 must go that way. Opposite of -3 on this side becomes on that side. So you have on this side now 8x minus 6x. We have +4 +3. Okay, Mr. Staff, are you copying these things down? Good, well done. 8x minus 6x is 2x. 4 add 3 will give us
7.
Okay, don't worry now that the 7 is now a multiple of 2, that's not a problem. Okay, opposite of time by 2 is?
Divided by 2.
So 7 divided by 2 is?
3.5.
3.5, 3.5. Okay, that question is done. So let's quickly, everybody done that, let's move on to the next bit.
Yeah.
So I'm looking for one. Next question please folks. Smia.
I think it's false.
Okay, that's lovely. Can you make that one question a bit bigger? That's excellent. Question number 15. One sheet of paper is 9 times by 10 to the minus 3 centimeters thick. Mark wants to put 500 sheets of paper into this tray. The paper tray is only 4 centimeters deep. Is the paper tray deep enough for the 500 sheets? you must explain your answer. So you can't say stuff like the answer is yes or no because I know it is. Yeah, that won't cut any mustard on the examiner. So let's have a look. We've got 500 sheets and each sheet is 9 times by 10 to the minus 3. Okay, that's the calculation that we need to do first of all. So 500 times by 9, let's do this part first. 500 times by 9. 500 times by 9 will give us 4,500. Okay, time by 10 to the minus 3. What does that mean by time by 10 to the minus 3? When you have 10 to the minus 3, it means that this number here, if you decimalize it, you have to divide it by 10 thousand. So 1, 2, 3. The minus 3 means move back 3 places for that number. So the answer becomes 4.5 centimeters. And so the answer is no, the tray is not deep enough. Okay, it's not deep enough. It is half a centimeter short. So we need a corner half centimeter, but it's only 4 centimeters. Okay? So we explain that. Let's move on to the next question, folks. Copy that down.
Yeah.
Okay, we need to be quick time so we can try to finish this paper off. Question number 16. Beautiful, nice and big. I like that. And that's it. The normal price of a television is reduced by 30% in a sale. Now, let's quick question. Let's have Rutaba. What's the normal price of a TV? Normal price. When you go to shop TV, normal price is called how much percent? 100%. So the normal price was 100%. It's been reduced by 30%. So how much is it worth now? 70%. So the sale price is. So we can say now that the £350 is equivalent to 70%. Are we happy with that, folks?
Yeah.
So that sale price is now worth 70% of the original value because they're not 30% off. What we need to do now is work backwards from 70% to 100%. So how do we get from 70% to 100%? First we'll go from 70 to, if you want to do it like in 2 quick steps, 70 down to 10 and then 10 up to 100. Excellent. So now how do we get from 70 to 10?
Divided by 7.
How do we get from 10 to 100?
Divided by 10.
Okay, that's just a way for us to think about it. It's non-calculated paper, so we don't want to be busting ourselves up with any dividing by decimals. So 70 divided by 7 is 10. 10 divided by 10 is 100%. Now 350. What you do on the right, you do on the left. 350 divided by 7 is, folks?
50.
50. And then 50 times by 10 is?
500.
500. So the original price of the normal price of the TV was £500. Okay, folks, let's move on to the next question. Please, give me the next question. Come on. Folks, we got all that out?
Yeah.
Yes? Oh, this is my favorite question. Oh, lovely question here. Yummy, yummy. Right, okay. Question number 17. Ideally, we want to be on that side of the board, but then I'm going to have to do what we have at the moment. Just change colours. Okay. Move the question that way.
This way?
That way.
That way?
That way, a bit more.
That's it, that's all it goes.
Okay, that's fine. Take it up a bit. So meet the pond in the shape of a prism. Question number 17. We have the height of the 1.3 meters, half a meter at the shorter end, 2 meters wide, so 2 meters long, 1 meter wide. Okay. The pond is completely full of water, so Meet wants to empty the pond so he can clean it. So Meet uses the pump to empty the pond. The volume of water in the pond decreases at a constant rate. The level of the water in the pond goes down by 20 centimeters in the first 30 minutes. That's very important. So let's work that out first. So we lose 20 centimeters which is how much of a meter? How much of a meter? 20 centimeters? 0.2 meters, which is that divided by 100. That's how much we lost in the first, how much time?
Half an hour.
Half an hour. It's taken half an hour to go down to that level. So what we're going to do now, we're going to work out the volume of the water that has actually been drained out in the half an hour. So this shape here, Ramiz, look, this shape here, that's like the 3D shape which I've drawn, is called a, what's it called? Cuboid. Thank you, Ramiz. So we have a cuboid. The volume of a cuboid is length
times width times height.
So this is going to give us the volume of
The cuboid.
this cuboid of liquid that's come out. It's volume of liquid. So the length of this is 2. And the width is, what's the width?
1.
1.
And what's the height?
20.
0.2.
0.2. Okay, folks, this is where students make mistakes. They've got meters and you've gone down by 20 centimeters. 2 different units. Make the units consistent. So we work in meters. Do not use 20 here. Do not use 20 centimeters because these are all meters. So you must use 0.2. So then, Umar, are you happy with that?
Yeah.
Because that's meters, and that's meters. You can't go from meters to centimeters. You'll make the question wrong. So 2 times by 1, folks, is
2.
and 2 times by 0.2 is
2.2.
okay. So the volume is equal to 0.4 meters cubed per half hour. So 0.2 times by 2 gives us 0.4. That's how we've lost 0.4 meters cubed of volume in half an hour. So how much have we lost in a full hour?
0.8.
If we are losing, Rutaba, 0.4 meters cubed per every half an hour, how much are we losing per hour? What do we just do the number? We double the number to work out what the hourly rate is at the same rate. So in 1 hour we will lose 0.8 meters per cube. That's our flow rate, constant. Okay. Now, okay, goes the next question on the bottom says here now. That's the first part of the question. We worked out how much volume is lost. We worked out the flow rate. Now the question goes, work out how much more time Sumit has to wait for the pump to empty the pond completely. So this was the important part to work out how much water was lost. We know how much time. We worked out then the hourly rate of water lost. Now we need to work out how much water is left and how long that will take to pump out. Okay, now, Mr. Umar,
Yeah.
this height was originally, how big was the height?
1.3.
1.3, and we lost how much?
0.2.
So how much is left over now?
1.1.
1.1. Okay, let's have Afira and Ifra. Ifra, the original height is 0.5 at the shallow end, and then we lost 0.2 meters. So how much is left over? 0.3. So we have to adjust the values on the table, on the diagram. Now, okay, next question. Prataba, this original length here, has that changed? No. So this is still 2 meters long, yeah? Are you happy with that? Now we need to work out the volume of this. What kind of shape is this in me? It is called a trapezoid. Because it's a trapezium but in 3D. Right, what I'm going to do now, I'm going to rub off the top part so we don't get the two things confused. I'm going to rub off this part for the moment. Okay, so I'm now going to focus on okay, we're going to focus on this trapezium and then its thickness. The thickness is 1 meter. Now, if you want to work out the volume of a 3D shape, let's start doing some rules for that now. So the volume of a prism is equal to the area of the face, I call it, times by the thickness of the shape. That's one way of looking at it. Now the area of the face, this face, here's the face here. The face is here. This is the face. Now the face is a trapezium. Who knows the formula for the area of a trapezium? The area of a trapezium is, don't all shout out once.
A plus B divided by 2 times 6.
Thank you, Samira. Okay, at least I know something I can read in the class. Okay.
What does times
A plus B divided by 2 times by the height.
the top? So you
Thickness.
Area of face times by thickness. Yeah, happy with that?
Yeah.
And the thickness here, the thickness is 1 meter. Done. Now, let's start putting in some of the values in. What I'm going to do, I'm going to actually rub them letters down, start putting the values in. So for those of you following us at home, please do yours work slide down. I'm running out of space. Let's see, maybe we'll have a cope. So the A and the B are the two parallel sides. So I'm going to call this one A. I'm going to call this one B. So we can do here 1.1 for A, add 0.3 for B, divided by 2, times it by the height. What's the height of the trapezium this way? The height is this way. That one, that's the height. 2 meters. I know it looks like a length, but it's just the way the trapezium is turned around. If these are parallel sides, then that is the height, regardless of its orientation in this picture. Okay? Okay, we're happy with that, Hamza? Put all the values in now. So 1.1 add 0.3 is 1.1 add 0.3 is 1.4. 1.4 divided by 2 is 0.7. Then 0.7 then times by 2 is back to 1.4. And then 1.4 times by 1 is still 1.4. So these two in a sense will cancel each other out, so we end up with 1.4 meters cubed. 1.4 meters cubed worth of volume left. Now, here comes the last part. We haven't finished yet, folks. I know it sounds like, looks like a long question. So, how many marks is that question?
6.
6 marks, folks. This is 6 mark question in the examination. They want you to sweat a bit, at least. If you're not sweating, then you haven't done enough work. So 1.4 meters cubes in the bottom part, Hamza, yes? You have to drain it out at what rate? 0.8 meters per hour, yeah? So now we have to say, here's the last part of the calculation. Just change colour. So we got 1.4, we have to divide it by 0.8. So we do 1.4 meters cubed. It's flowing out at 0.8 meters cubed per hour. We're going to work that out. Okay, 1.4 divided by 0.8. Let's do it over here. When you divide it by a decimal, okay, we can do it 2 different ways. We can turn this into a fraction, turn that into a fraction, or we can just turn this into a whole number and do the bus stop method. So 0.8, we're going to turn it into a whole number by multiplying by 10. So I need to turn this number into a whole number. So if I turn this by 10, I have to times.
Not by 10.
So the question gets transformed into 14 divided by 8. That's how we deal with decimal division. To convert the number that we're dividing by into a whole number, and whatever we do to this number, we do that number. So we got 14 divided by 8. Is it okay? 2 minutes left. So the 8 goes at the front, and the 14 goes in here. Right. So, how many 8s goes into 1 is? You can't fit 8 into 1, so you have the 1 left over. How many 8s go into 14 will be? 1.
6.
Okay, and remainder 6. Thank you. So how many 8s go into 60?
7.
8 times by 7 is?
56.
Okay. Remainder 4. Put another 0 down. How many 8s in 40?
5.
Okay, hang on a second. Let's just. $1.75 hours. Now, before you go any further with this question, you think you're finished. When you give to answer in time, do you ever say to your parents, I'll be back in 1.75 hours?
No.
No. If you say that, your parents will be looking at what are you talking about? 1.75. We don't do decimal time in that sense. They must convert into minutes. So, Mr. Saf, 0.75 is how much as a fraction? 0.75 is?
3/4.
3/4. So 1.75 is 1 and 3/4 hours. That's okay as an answer. 1 3/4 hours or 1 hour and 45 minutes, and so on and so on. But we shouldn't give the answer in decimal. That's not good. Okay, folks, are we happy with that long question? Hamza? Okay? Okay, folks, I'm afraid that's how much work you do for that question. Okay, Ismail, can you give us the next question, please? Okay, yeah, okay. Yeah. Oh, my favorite question. Okay, that's lovely. Okay, folks. Right, let's carry on the next question. Question number 18. Solve the simultaneous equation. Feel keep an eye on the video, please, yeah? 4x plus 7y equals 1. 3x plus 10y equals 15. Okay, now, when we do these questions, we're going to use the elimination technique. Okay, we're going to eliminate either the x or the y. We look at the values. 4 and the 3 are the x coefficients, and 7 and the 10. Right. We're going to decide to remove to eliminate or to the x coefficients. Okay, how do we eliminate the x coefficients here? We need to make the coefficients either opposite or equal. So if we got 4 and 3, how do we make 4 and 3 equal? We multiply the 4 by the
3
and the 3 by the
4.
Excellent. By the way, we're not just multiplying the x, we're multiplying everything, yes?
Yeah.
On that line. So 3 times by 4x will give us an answer of?
12x.
Okay, and 3 times by plus 7y is?
21y.
And 3 times by 1 is?
3.
3. 4 times by 3x is?
12x.
4 times by plus 10y is?
40y.
And 4 times by 15 is?
60.
60. Okay, so this is what we're going to be working on now. Okay, Taba, you with me so far?
Yeah.
So we're looking at these coefficients of x here, and now that they are equal, we are much more happy. We can eliminate them by minusing them, by subtraction. Okay. As we said before in the previous videos, when we're doing simultaneous equations, when we are taking away simultaneous equation, we don't have to always go down, we can also go up. But if you go up, you must go up in everything. You can't go up and down. So what I'm going to do now, I'm going to do 12x minus 12x, that gives us 0x, nothing. Gone, finished. We have plus 40y minus 21y, that will give us?
19.
Not minus.
19y.
19y. The whole point of going up is that we wouldn't get a minus answer. No, it's 40, that's going up plus.
Oh, you know.
Going up. 40y, take away 21y gives you 19y.
Okay.
Next is 60, take away 3, we're going up.
57.
57. Okay, now.
Read the answers through.
Okay, now. Remember we're doing videos, we've got to explain what we're doing. Y has been multiplied by 19, opposite times by 19 is?
Divided by 9.
So 57 divided by 19 is?
3.
3. Now that we got the value of y, we eliminated x, worked out the value of y, we can put the y back into the equation and work out the value of x. So let's have a look. Let's use the original equation here, 4x plus 7y is equal to 1. What have we just worked out the value of? We worked out the value of y, which goes into here. Do not substitute it for x by mistake. So we have 4x plus 7 times by 3 is equal to 1. Okay, we happy with that so far? Right. 7 times by 3 is 21. Now, we need to work out the value of x, we need to solve it. So x has been first of all been times by 4. And then it's been added by 21. So that's the second action, that's the first action. Opposite of add 21 is? Minus 21. So 1 take away 21 is? Minus 20. Okay, now, Opposite time by 4 is?
Divide by 4.
Divide by 4.
5.
So we say x is equal to
Minus 5.
minus 5. Minus 20 divided by 4 is minus 5. Okay, folks, are you happy with that question? Yes, let's give me the next question, please.
So you're gonna have a sore throat after this.
Nah, inshallah, should be okay. Inshallah, bismillah. It's my best session of the week, man. It's lesson. These lessons. Okay. So write these numbers, notice me, make it nice and big. Maybe a bit more bigger. Okay, bring it across. Okay, take it up. Lovely, stop there. You've got to put this in order of size. Right, what does 5 to the power of minus 1 mean?
1/5.
0.5.
1/5 means the reciprocal. The minus means the reciprocal turned upside down. 0.5 is 0.5, that as it is. Minus 5 is minus 5. Anything to the power of 0 is always unos. Unos dos. Now we're going to put these in order. So I'm going to put these ones in order first and then we'll replace them with the original values. So the first smallest one is,
Minus 5.
5.
and then the next one after minus 5 is,
0.5.
0.5.
okay, well 1/5 is 0.2, isn't it?
Allah. 0.2.
1 divided by 5 is 0.2, so that should be next, isn't it?
Yeah.
Yeah?
Yeah.
So minus 5, then,
0.2.
and then 0. Well actually,
1/5.
1/5. And then
0.5.
Then 0.5 and then,
1.
Minus
and then
5.
1. Now, this is my rough answer. We have to replace this with the original values. So Ramiz, minus 5, was it originally minus 5?
Yeah.
Yes.
No.
What was 1/5 originally?
5 minus 1. 5
Five.
to the power of minus 1.
Lovely, that was originally that. 0.5 was that originally?
0.5.
Lovely, and 1 was
5 to
originally?
the power of 0.
Okay, thank you. What did you do really there? Thank you Ramiz, you saved the day. Okay, are we happy with that question, folks? Right, okay, Smia, give me the next question. Okay, we got about... Ooh, I love this question. This question is nice.
Oh god.
What do you mean? Didn't you enjoy it? Right.
Oh, no.
I don't think my students enjoyed this next question. Okay, let's have a look. It says ABCD is a square. Okay, straight away if it's a square we can start doing some certain things. If this is 4x, then this will also be 4x. Then it says here M is the midpoint of DC. If that's the middle of this line, that means this top part is
2.
and the bottom part is
2.
x. If that part is x and altogether is 4x, what's this part?
3x.
3x. Okay. Let's find an expression in terms of x for the area of the triangle BMN. The easiest way to work it out is to work out the area of the big square and minus the area of the three triangles. Yeah? So that's the concept, that's the idea we're going to use. So Mr. Hamza, we're going to work out the area of the square and we're going to minus this first triangle here. Triangle A, and then we're going to minus the area of triangle B, and then we're going to minus the area of triangle C. And that will give us the shaded area. So the big shape minus the 3 bits will give us what's left over. So that's the concept. Now, how do we work out the area of this big square Ifra? So we have 4x and 4x the length and width. So how do you work out the area of a square anyway? So this area is the shape here now. What are we going to do? Times them together. Length times by width. So we have 4x times by 4x, which is length times by width of this big square. 4x times by 4x will give us an answer of 16x squared. Now, these next 3 triangles, we need to make sure we use the area of a triangle formula. What's the area of a triangle formula?
Base times height divided by 2.
And that is the area of a triangle. Okay, are we happy with that? Right, now, I don't think we're going to have too much space here because what we're going to do, work out the area of A, B and C and then just put the answer over here, okay? Let's work out the area of A over here. Area of triangle A. Where's the triangle A? This one here. So what's the base? Okay, we thought about the base is 3x and the height is 4x. So it's going to be 3x times by
4x
divided by
2
2. 3x times by 4x is 12x
squared
divided by 2. So
6x
the area of A is equal to 6x
squared.
squared. So I'm going to do the stuff there and I'm going to copy it here. Now let's work out the area of triangle B, which is that one here. So let's change colour over here now. So area of this triangle here. So the base here is, what's the base?
1.
The base is,
Oh, 4.
the base is, okay folks, have I lost you? What is, can you,
One.
okay, no, let's try that again, okay. Can you read what he says over there?
X.
X, thank you, right. So the base is X. Okay, yeah, we know X coefficient is 1, but that's not the same as X.
Okay.
Alright, and the height is 2x.
2x, yes.
So the base times by the height and then we divide it by 2. So x times by 2x will give us 2x squared divided by 2 is,
X squared.
so we put that over here. Here comes the next part. Area of C. Where's C? C is over here. Tired? Here's your base, which is 4x, and here's your height, which is 2x. So let's work out the area of that. I'm going to work it out yeah. Right. The base is 4x times by the height 2x.
2x.
So we have 4x times by 2x, and then we divide it by 2. Base times by height divided by 2, which will give us 8x squared divided by 2, which gives us
4x squared.
4x squared. Right, hopefully this shouldn't be too difficult now, the last part. 16x squared take away 6x squared will give us 10x squared. 10x squared take away x squared will give us 9x squared. Take away 4x squared will give us. So the area of B and M and they've actually written as BMN. So let's just use the way that they've written it. With equal to what's the answer again?
5x squared.
5x squared. Folks, there's another way of doing it as well, but that involves square roots and stuff. I'm trying to show you the easier way. Okay? Right, let's give us the next question, please.
Cumulative. So you had to find out the homework now?
No, I'd rather finish off the work.
So you got 6 minutes.
Okay, I'm sure you people don't mind waiting for a bit.
No, and the thing you got 6 minutes.
Okay. Remember whatever you say is being recorded, it'll be eternally on there until the so be careful what you say. Okay, the table below shows information about the height of 60 students. On the grid opposite, draw a cumulative frequency graph for the information in the table, which most people use. Yeah, cumulative frequency. Cumulative means like a running total. So you need to increase, first of all, your table with one extra column. So feel free in the examination to put the extra column in. So what we need to do now, we need to work out the running totals. So the first total so far is 4. Prataba, what do we add next?
5.
The 5, and that gives us a total of?
9.
And then we add, what we add next?
16.
And that gives us a total of?
25.
You guys are really good at mental math, mashallah. Excellent. Oof.
You're welcome.
52.
Amazing stuff.
52.
25 out of 27 is?
52.
52.
57.
52, answer means you're running too fast now. 52, add the 5 will give us?
57.
57, add the 3 will give us?
16.
Alhamdulillah. Excellent folks, well done. Now, when you plot the cumulative frequency, the graph on the next page, when we go to the next page now, not yet, which values do we use? So cumulative frequency will be your
1.
y-axis. And what will be plotted on the x-axis?
The number of students, not the height.
Which is the one.
Which value? This first value, the second value, or the middle value?
Second.
Okay, whenever we plot cumulative frequency, we always use the
Second.
boundary points, the end. Okay, the second one. So these are my x coordinates. Okay, and that's my y coordinate, x coordinate, y coordinate, x coordinate, y coordinate, x coordinate, y coordinate, x coordinate, y coordinate, and x and y. Okay, folks, are we happy with this particular table here? Yes, all done. I'm gonna have to rub this stuff off and then I'll borrow one of your papers because I can't see it again. Right, so give us the next page. We have to draw it now. Okay, folks. Right. Make it. Okay, that's it. That's lovely. That's lovely. 4 minutes left for the video. Okay, lovely. Okay. Right, can I borrow your table, please?
In the middle. There you go.
You only do this curve. Okay, so we're going to first of all plot. Is it 140 or 150?
150.
150, and what's the height for 150?
4.
4. Okay, folks, bear with me for 1, 2, 3, 4. Okay, and the next one is 160. What's the height for 160?
9.
Okay, and that's over there.
Yeah.
And the next one we're going to do 170, which is?
25.
Okay, and the next one is 180, which is?
52.
52. Then 57.
And the last one is?
57.
200, which is 60. Sorry, 200, which is?
60.
No, you got 90 left.
Okay, sorry, pardon me, 190 is 57, yeah?
Yeah.
190 is
57.
50. And the last one, which is 200, which is?
60.
Okay. Quickly plug your points on there. Mr. Ramiz. Okay, right. How do I take that? Now, please, why do not use a ruler for the next activity? I want a nice, smooth curve. So let's try to do a nice, smooth curve. Should get something like that. Okay. So how many minutes left for? 2 minutes. Okay, good. Let's just quickly finish up this question. Okay, folks, I can't move the graph now. I need to see the next part of the question.
The medium.
Okay, the question says find an estimate for the median. The median is the
30.
middle value, the 30th. So how many values did we have?
60.
60 values. So we're looking for the 30th value, and the 30th value is where?
There.
So we're gonna go across and come
Down.
down.
173.
Okay, so we go across. Okay, and then you come down, and mine's going to be roughly.
172 upper.
Okay, mine's is roughly 172. Roughly, yeah, 172.
Yep.
So my median is here, 172. centimeters. Okay, what's the next question, Ramiz, on that question?
Interquartile range.
Interquartile range. Interquartile range, Umar, is to do with what? This is the middle value. This is the halfway. So the interquartile value is to do with the quarter value and the three-quarter value.
Yeah.
So if this is the halfway, if I want to look at the quarter of a way, what's the quarter of a way?
15.
15th value. So 10, 11, 12, 13, 14, 15. So this is going to be, we're going to start the calculation here. That's going to be, and what's 30 add another 15?
45.
Okay, 45, 40, 41, 42, 43, 44, 45. Okay. So the lower quartile calculation starts from here, Ifra, and we go across, hit the graph and come down. So let's change color so we don't clash with the color. Are you okay with that? We do. So. Okay, back to one. Right, okay, so a quarter of the way up, draw a line across, bring a line straight down. 3/4 way up. This is where the lower quartile starts from and the upper quartile starts from. So let's bring our line straight down from there. And that is roughly. This value here, folks, is called the
Low quartile.
and this value here is called the
Upper quartile.
okay. Now from my graph here, 160, 160, 162, 63, 64 is about 165. Okay, we most got 165?
Yeah.
Yeah, and the next one, the upper quartile value from here, 170, 171, 1, 2, 3, 4, 5, 6, it's near 6. You know what, 176, folks?
Yeah, I got 177.
Okay.
Yeah, I got 177.
Okay, 176, 177. I'm going to go towards 176 for the moment. Now, if you want to work out the interquartile range, it's going to be the upper quartile minus the
Low quartile.
okay, the upper quartile according to this graph is 176. We're going to minus the lower quartile, which is 165. So 176 minus 165 will give us a total of 11. And the answer is 11 centimeters. Done. Okay, folks, can you feed me the next question, please? The next question.
Next question is.
Ooh, I love this next question. Okay, right.
Can I not go home?
Okay, folks, so then, my students are already dreaming of going home. Oh, if only.
Oh my god.
Okay, folks, what question? How many questions you got left in the paper?
We got
6.
Yeah, no problem. Finish that easy time.
no.
Yeah.
7.
Okay, well, let's just finish the terms. P and Q are two triangular prisms that are mathematically similar. Okay, so let's have a look. We got to work out. Okay, what is the? So we got area there. We got a length, and we got a width. Or the thickness of shape. Okay, what's the actual thing we're going to work out for this question? Now, I can't see what the question.
That is it? That's all the question?
Okay, these are mathematically similar. No, it wasn't all the question. That's
That's it.
yeah, that was missing. So to work out the volume of prism Q. So we're going to work out the volume of this similar shape here. How do we normally work out the volume?
Base length times base times.
Okay, now if we know the volume of this one, can we easily work out the volume of that one? Yes.
Yes.
First of all, let's work out the volume of this shape here. The volume of this shape is equal to the area of the face times by the thickness. What's the area of this face?
10 centimeters.
And what is the thickness?
15.
And what's 10 times by 15?
150.
So volume of the original shape, is 150 centimeters cubed. And then we're going to take it to this volume, which is the volume of the large shape. Now, when we are dealing with similar volumes, what do we do with the scale factor? We have to multiply by the scale factor cubed. Because it's volume. Remember that from the last lesson? Yeah. It's coming back now. So, we need to establish the scale factor first of all. So, Rutaba, what do we do? How do we look at the scale factor?
12 divided by 6.
So, we look at this length here and look at this length here. This is my original length. This is my large length. Okay. So, 6 times by the scale factor is equal to 12. So, this original length times by the scale factor is 12. So, Mr. Saf, 6 times by? Excellent, well done. 6 times by 2 is 12. So, our scale factor is clearly 2 from looking at the similar lengths. Now, scale factor cubed. So, we have to do 150 multiplied by 2 cubed. Oops. Actually, worked out 2 cubed, which is 8. Alright. Right. 150 times by 2 cubed will give us the new volume that we're looking for. Now, 150 times by 2 cubed is 150 times by 8. Okay, 150 times by 8 will be 100 times by 8 is 800. 50 times by 8 is 400. So 800 and 400 is
12,000.
1200.
Okay.
Okay. Something to do. Are we happy with that, folks?
Yep.
Yeah.
Okay, so that's the volume of that question. That question done.
We did another one.
Is that all that question, all of it done?
Yeah.
Okay, let's move on to the next question. Normally it's on there anyway. Okay, folks, right. Nice, lovely question. Simplify this at the moment. Folks, before you go any further, I've seen students do this on exam papers. Don't even think about cancelling it like this. Do not even go down that road, please. That's wrong. And divide that by 2, divide that by 2. You can't do this. What we have on the bottom is a sum. It's a quadratic equation. What we have on top over here is also like a sum in the bracket of the product. You can't do that kind of cancelling. That's illegal cancelling.
Do you expand the bracket?
No, don't expand the bracket. We need to factorize the bottom first. So, let's copy the top across. So we got 4 bracket x plus 5, which we copy across. And we got x squared plus 2x minus 15, which we've got to factorize. So, who remembers the factorizing technique? 2 numbers
Add together.
that multiply to give you minus 15, but add together give you plus 2. So, minus 15,
X plus
we can have 3 and 5.
X plus 5, x minus 2.
So which number should we use?
X plus 3.
3 and 5.
Okay, which 3 and 5? Minus 3 and 5 or plus 3 and minus 5?
Minus 3.
Minus 3 and 5, excellent. Why minus 3 and 5? Because when you add them up, it gives you plus 2. And we need a plus 2. Okay. Now, what do you realize straight away? There's something similar from top to bottom? Thumbs up. This is the same as? That was the whole point of the question. So we left with an answer of 4 over
X minus 3.
x minus 3. Question is done. Next question, please, folks. Question is done.
You're like a radar and you got 16 cylinders.
Inshallah. Okay, right. Nice. That's okay. Okay, right. Right. Yeah, that's right. Because once we do the work on that, then we're going to get stuck for the graph as well. How do we move up and stuff. So, what we can do, let's do some, make that nice and big. We'll do that part first, and rub it off, and then I'll borrow his text, and then we do the next one. Okay, don't worry about that. That's lovely, that's better smear. Okay, what question is this? I can't see now. 24. Bill works for a computer service center. The table shows some information about the length of time, T minutes of the phone calls. Okay, so we have time and the number of calls. The number of calls, another word for that is?
Frequency.
Okay, and this one is our class. Okay, not like the class that we sit in, but the class is the size of the data. Right. We need to draw a histogram. Histograms to do which formulas? Okay, Mr. Can you also text me that later? Okay, so what do you just text them. Tell them you're just finishing off. Okay. What we need to do when you do frequency density, when you do a histogram, we're talking about frequency density. Smith, is that label on the diagram, by the way?
Yeah, it is.
Yeah? If you see the word frequency density on your diagram, it's definitely histograms. So let's work out the formula. So we say here that the frequency density is equal to the frequency divided by the class width. That's the formula. Okay? So we need to work out the frequency density. Now, this is the frequency. We need to look at the class width. Class width, how wide that data is. So how wide is that data? We'll put the class width here. So 0 to 10, that has a width of, what's the width? 10. Okay, 10 to 15, the width between 10 and 15 is?
5.
15 to 20?
5.
20 to 30?
5.
Okay, and 30 to 45? 15. Okay, now we need to work out the frequency density.
So we're going to complete the whole paper.
That's the intention, to give you the maximum benefit of this session.
So the next
Unless you guys want to go home and watch TV and stuff, you find that might be more beneficial towards your examination. That's all you're going to do when you go home, so go home and put the TV on. Okay, remember it's Friday night, we can spend doing maths together. Beautiful night for maths.
No.
Frequency density, yes. Lovely. phone back up there now. So, Umar, if I look at the frequency density, I gotta get the frequency and divide it by the class width. Frequency divided by class width, yeah? So it's 12 divided by 10. So what's 12 divided by 10? 12, if you divide it by 10, will give us
1.2.
1.2.
Yes, you got calculator.
And the next frequency is 15. We have to divide it by the class, which is 5. So 15 divided by 5 is?
3.
And then we do 13 divided by 5.
3.2.
Okay, 13 divided by 5 will give you 2 and 3/5, which is equal to 2.6.
That's close.
Okay, next one is
1.8.
18 divided by 10. Remember, this is a non-calculator paper. I hope none of you are using calculator.
1.8
1.8. Next one is 3 divided by 15.
is
That's nice.
5.
3 divided by 15 is equal to, divide that by 3, divide that by 3 is equal to,
FC.
So it's 1.2.
okay, as I feel always said it was not 2. Okay, are you happy with that, Tawba? What we just done there? Okay, folks, are you happy with those calculations? If have you got that down? Umar?
Yeah.
You okay?
Yeah.
Good. Right. We're going to have to rub all this stuff off now. I'll have to borrow one of your sheets to do the next part. Has everybody got that table down? Probably.
Yeah, down.
Okay, folks, stop dreaming about TV. Okay, so come on, bring it up and make the graph nice and big. Okay, bring it across. Just trying to nick someone's work. That's beautiful. This is the frequency density. So I just take it notch up, little teeny bit up. Beautiful, lovely. Time on the bottom. So I'm looking at Ramiz's work here. We got 0 to 10, then 10 to 15, is that right?
Yeah.
And then we got 15 to 20, and then 20 to 30. Remember, this is not a bar chart. We have equal length. We will have unequal length, so expect it. So then 30 to 45.
45.
Okay, then. You happy with that now, folks? But where the boundary points are. Now, frequency density we worked out. It will give us our height. Now we've got to go up to 3, isn't it? So that 10 squares there, 10 little squares is 1, and then the next one is 2. So we're just calibrating is 3. Yeah, are we happy with that?
Yeah.
Now the first one, Ifra, is what's the height of the first one?
1.2.
1.2.
2.
1.2 is over here. Okay, let's change colour. Come with this. Happy? So go up. Okay, for the moment, folks, I'm just going to do this freehand. I'm sorry about that, folks, because just running out of time at the moment. Students need to go home. Okay, and then time to go home. Okay, next one we have 10 to 15. That one has a frequency density of 3. So that's going to go all the way up to here and across. Folks, can you please make sure when you're doing this paper for homework and for the exam you use a ruler. I'm not using ruler because it was only a bit short of time. The next one is 15 to 20. 15 to 20 has a height of 2.6. So it means 2.1, 2, 3, 4, 5, 6. How wide is it? That wide. Okay, next one is 20 to 30, has a height of 1.8. 1.8 is... two little squares below it. And the last one, Rubiz, is 0 point?
0.2.
0.2. Done. From 30 to 45 is 0.2 height. Lovely. Okay, we nearly finished the paper. Just stay with me, folks. Right. Okay, so come on, quickly. Next question, please. Come on. Feed me the next question. Make it a bit smaller, it's just way too big. One more. That'll do. That's lovely. Number 25, the expression x squared minus 8x plus 21 can be written in form x minus a squared plus b. For all values of x, find the values of a and the value of b. This is called, what's this called, Taba? What's this kind of math called? It's called completing the square. Thank you. Now what we do first of all, we copy down the x from the x squared, and we have to half the coefficient of x. What's half coefficient minus? What's half minus 8? Minus 4. Close it off. Square it. Okay. Now we need to do plus or minus an adjustment. So we need to do this first and see how far we are when we do this to our original one there. Okay, x minus 4 squared. Let's do it on the side. Okay, x times by x is? X times by minus 4 is?
Minus 8.
Minus 4 times by x is? Minus 4x. Minus 4 times by minus 4 is? Plus 16. So x squared, so that will give us a total of? Now I want you to compare what we have here, on a circle in red. X squared and x squared, do they match?
Yeah.
Minus 8x and minus, do they match?
Yeah.
Does the plus 16 match with the plus 21?
No.
No, this is where the adjustment comes in. So we got to go from plus 16, we have to adjust it and get to plus 21. What's the adjustment going to be then? So how do we get from 16 to 21? We need to be at 21.
At 5.
So plus 5. So the adjustment becomes?
Plus 5.
There we go. So the value of A is the value here. What is A? A has a value of?
Minus 4.
No.
5.
There's A.
Yeah, 4.
X minus the A value, so the A value is 4.
Yeah.
Okay, what's the B value?
5.
The B value is here, so we have here, look. Okay, plus the B value, so we have 5. Okay, are we happy with that?
Yeah.
So that gives us the A and the B value. Lovely. Okay, let's take it up straight quickly. I need to put this off for the moment. Alright, it goes here now. The minimum point of the curve is M, write down the coordinates of M. What do we just work out? X, we go to A is equal to?
B.
4. And B is equal to?
5.
5. Okay. That actually, when the whole point, one of the points of doing completing the squares, we can work out the maximum minimum values of the graph. The A and B value are actually the X and the Y coordinates. So your A equals 4 is really your X coordinate. B equals 5 is really your Y coordinate. So these two values can be literally just lifted up from the first part of the question and plunked straight into here. So they correspond to this point here of the graph. X and Y. So the X value is 4 for the minimum part of the function, and the height of it is 5 for the minimum part. So 4, 5. So write down the coordinates of M, and that's the answer. Coordinates of M would be, the answer would be?
4, 5.
4, 5. Done. Next question please folks. Come on to me, the next question.
What is that? Look at it. Sir. You haven't got it. Yeah, 11 seconds.
Stop.
9.
Okay.
8.
Hey, nobody can't figure it out.
Where did you send it home then?
It's right down. Can you copy it? Right. Okay. So we can make that a little bit bigger, please.
Yeah.
That's lovely. Question number 26. Fiza, she's Fiza? Fiza has 10 coins in a bag. There are 3 £1 coins and 7 50p coins. Fiza takes at random 3 coins in the bag. Work out the probability that she takes exactly £2.50. How do we make £2.50 with £1 and 50p's?
£1
£1 add £1 add.
50p.
That's the only way you can make £2.50, isn't it? With 3 coins.
Yeah.
Okay, now let's think about the 3 different ways we can make £1.50. Sorry, £2.50. So we make 150, or we can have 1 plus 50 plus 1, or we can have
50 plus 1 plus 1.
no, you can't have 50 50 because it won't make £2. You're going to use the 3 coins.
Oh.
So them are the 3 different ways. Them are the 3 only ways we can make £2.50. So work out the probability that she takes exactly £2.50. That's these 3 ways. So let's have a look. So probability of £2.50 is equal to the probability of a £1 and the probability of a £1 and the probability of 50p. Is that right?
Yeah.
That's the first way. Or we're going to do the probability of a £1 and the probability, of a 50p and the probability of a £1. Okay. Even though I've written here 1 add 1 is 2 add 2, so I've adding the money, but in probability I'm saying the probability of a £1 and the probability of a £1 and the probability of 50. We're not using plus here. We're using and to indicate this item and that item. Okay, I need to rub that off.
Is that it?
No, let's the last part. Or
50.
what's the last way again? What was it?
50 add 1.
Or it's going to be the probability of 50p first and the probability of a £1 and the probability of a £1. And this is the fun bit here. Now, what does the and mean in probability?
Add times add.
Okay, right, I'm getting both answers simultaneously, mashallah, simultaneous equations as well. And means times. So Taba, what does O mean then?
Divide. Minus.
Add.
Well, that wasn't given by Taba's answer. Just want to clear her name to the video. It's add.
Yes.
Okay, so this one means times, this one means times, this one means times, this one means times. Beautiful, mashallah. Alhamdulillah. Right, what's the probability of the first one? How many £1 coins do we have?
3.
3 out of?
10.
So the probability of getting a £1 is 3 out of?
10.
Okay, what's the probability of getting a 50p coin? It's going to be how many?
7.
Out of?
10.
That's what we're going to be working with now. Right, okay. Now, this question is a question that involves without replacements. Obviously, when you're taking the coins, is she putting them back in, Taba?
No.
How about you put them back in? You tried. Okay, so probability of getting the first one is going to be what? £1 is going to be 3 out of?
10.
10. Now, once you take that £1 coin out, how many coins do you have now? How many coins do you have?
9.
9. And when you take that one out, how many coins do you have left over?
8.
8. So how many £1 coins do you have left over now? 2. And how many 50p's do you have? Do you have?
7.
So because you haven't taken that yet. That's how we do that. So the bottom numbers change. You've taken them out, so you have less number left behind. Next one. Probability of the first one here again is going to be?
3 out of 10.
3 out of 10 again. 3. And then you take a 50p out, so you're going to have 9 coins and 8 coins. So what's the probability of 50?
7.
7. So you got 3, 7 now. How many £1 coins do you have left over? 2 of them, because you two are taking one out.
Okay.
2. Okay, so we can copy down here. So we're going to start with 10 coins out of 10, out of 9, out of 8, because it's without replacement. So probability of getting the first 50p coin, Rutaba, is going to be 7 out of 10, yes?
Yeah.
Now we've got 9 coins left. Probability of getting the first £1 out is going to be 3 out of
9.
9. I've taken one of those £1 coins out. How many coins have I left for £1?
2.
2. Done. So we've got 3 times by 2 is?
6.
6 times by 7 is?
42.
42. Okay, we've got 10 times by 9 is?
90.
90 times by 8 is?
720.
720.
And that's going to be 3 times by... So this is the same numbers all over again, just different order. So that's also going to be another 42 over?
720.
And that's going to be also another 42 over?
720.
So how many 42s do we have? 3 of them? So what's the total for that? 40, 40, 40, and then add 6.
126.
126. 126, the bottom number does not change.
720.
720. So you can cancel this down. So you can just leave it like that. Simplify it if you're feeling a bit funky. Cancel it down. That's the probability of getting £2.50. Okay, next question please folks. Right. Okay, perhaps good value for money here.
Oh, this one's going to be long.
This is going to be a beautiful question. Who loves vectors? Please, if you love vectors. How come Zoli? I've got my hand up.
So you don't know what
Taba.
it is. Saf
Who loves
does.
vectors?
No.
I don't even know what one is.
Okay.
That's it.
Oh, that's one way of putting it. Okay, question number 27. PQRS is a parallelogram. N is the point on SQ such that this. So we got here first of all, vectors is all about direction and size. Okay, so to get from P to Q, you follow the vector called A. This vector is this long. It is in that direction and is this long. Okay. If you want to go from P to S, you follow this vector here called B. Okay, that one there. Now, because it's a parallelogram, what can we quickly kind of assume from a parallelogram? If this bottom one is A, then
Top one is A.
because it is
Parallel.
parallel, it's exactly the same vector, same size, same direction, but slightly further down. So that classifies this as also being A as well.
So the other two sides can be parallel.
Of course, because it's parallelogram. So this is B. So this one will have to be also have to be
B.
B. Okay, lovely. S to N and this is the part that students get wrong in the exam every time. They don't understand the ratio properly. Now, Mr. Faisal, Seth, sorry, 3 add 2.
1.
We got 3 ratio 2. So 3 add 2 is equal to 5. So the first part is 3 out of 5, yes? 3/5 of the ratio. N to Q has 2 parts of the ratio, which means it is 2/5 of the ratio. Now, find out A and B expression for SQ. I'm leaving it for that for the moment. We'll come back to that in a second. Write down in terms of A and B an expression for SQ. I've got to get from here to there. Now, can I go straight down there? Because we don't have a vector to describe. You can't, even though it's in front of you, we can see it. You can't go down that road. We have to go which way? This way and then that way. So S to Q. Okay, let's do over here. S to Q. If I want to get from S to Q, I've got to go first of all S to P. And then I've got to go from P to. This is my idea. Rotaba, S to P is what? Remember, B is going up and B is going
Down.
so it won't be plus B, it will be minus B. Okay, now plus PQ. Now P to Q, which direction are we going in? In the vector called? Plus A. Just A. So you're adding the A. Okay? So have you worked out the first part? Yes.
Never done this in my life.
Huh?
Never done this in my life, yours.
There you go, you're learning it. Learning something new. So, S to Q is equal to minus B plus A. Now, when we write the vectors, because when they do vectors, they make them bold print. We can't make a bold print. We put a little bar on top to indicate this is a vector. Okay? In the examination, that's made printed bold. You can't print bold because you're using the same ink unless you start writing again and again. So we can put a little bar to indicate this is a vector. Now, let's express N to R. We got to go from here to.
R.
Okay, what do we just worked out how to get from S to Q, haven't we? So we do know how to get from. So we can say from here to there is what is the vector called?
Minus B plus A.
Plus A. That's the whole thing. That's all of this. Now we have to go from there to N to R.
N. So going up. Diagonal.
Right. If you're going from N to R, can somebody give me a route from N to R? We could go
N to Q.
N to Q first of all, and then
Q to R.
excellent, lovely, beautiful. I like that idea. So we're going to say now N to R from there to there, because I don't know what that is at the moment. We can't go on that route. We're going to go this way, which is N to Q, which we do know how to do, and then we're going to go from Q to
R.
right. Now, what is N to Q? Remember, I said N to Q is 2/5 of the way. Yeah, 2/5. So the full vector is called minus B plus A, and this little bit here is called, it is what? 2/5 of minus B plus A. It's 2/5 of that. Because the whole thing is minus B plus A. That's worth 3/5, that's worth 2/5. So under the Q, this one here, we write down 2/5. What is Q to R, folks? Q to R is what? B. Okay, are we happy with that so far?
Yeah.
Now, The next part students fail, trip on, just multiplying it out and simplifying it. Now, 2/5 times by minus b gives us
Say that again.
2/5
Yeah.
times by minus b gives us minus 2/5 b. Okay, 2/5 times by minus b gives us minus 2/5 b. 2/5 times by plus a gives us
2/5 plus a.
2/5 a.
Oh.
And then add the b. Now, what we need to do now is simplify. Now we can only simplify like terms with like terms. So the 2/5 a, that doesn't simplify because there's no other a term. So you put that down first. So this part is over here. Now what will simplify, Ramiz? What we got left to simplify? We got the minus 2/5 b and the
Plus b.
plus b. Just think of it as a banana. I have one banana and I eat 2/5 of the banana. I have one banana, 1b, and I eat 2/5 of the banana. How many fifths do I have left over?
3.
3/5.
Of a banana.
3/5 of a banana. Here we go. Okay, now, if you want to be smarty pants and make it look a bit more fancy, what we do now, we factorize the fifth out. And that's your, so these two are your possible answers at the end. This one, unfactorized, or this one. And this will do as the answer for n to r. And that's the end of that question. Okay, are you happy with that, folks?
Yeah.
Is that nice and easy?
Yeah.
Told you GCSE papers are easy, yeah? Easy.
No.
Yeah. Okay. Good. Come on, folks.
Yeah, I'm that tired, yeah.
Okay, the last question. Okay, folks, I won't delay your pain any further. Let's do this nice. Please make it big, please. Make it big. Lovely. Delicious. The diagram shows the sketch of the graph y equals cos x. Folks, you need to learn cos x, the basic graphs with the main points on it. So let's have a look. So they gave you the maximum amplitude is 1 and the minimum is minus 1. Now this is one cycle of the cos curve, the cos function. So the halfway point of a cos function is 180 degrees and the maximum point is 360 of the one full cycle. So that would be 180, so half of 180 is
90. 270.
Okay, now lovely. So write down the coordinates of the point A. So Hamza, so that coordinate of A is going to be what? So A is going to be, the coordinate is going to be 90 along the x, and how high is it? Nothing. It's on the x-axis, it hasn't got no height. That point there has a height of 0. So the first one goes, write down the coordinates of point A. We've done it nice and quickly because we understand what these numbers are. You should have learned, you must learn those. Okay, so that's a cos function. You should know that that's one cycle, and the cycle goes from 0 to 360 and 180 and so on and so on. Okay, the next question, Smith, don't move it up, just read it out to me, please. The next question.
On the same diagram, draw a sketch of the graph of y equals 2 cos x.
Okay, now folks, what can you see the difference, Umar, between y equals cos x and y equals 2 cos x? What's the different part? Got 2. This 2 here acts as a multiplier. So what we're doing here, we're doing the same function, but after we've done the function, we are now multiplying by 2, stretching it. So we're multiplying each point by 2. So let's look at the main points. So this point here, 1 becomes, 1 times by 2 is 2. So let's put a mark there for 2. So that point goes to there. Okay, now 0. What's 0 times by 2?
0.
Still 0, so that doesn't move. Okay, that doesn't move. So that stays there. Okay, now, what is 180 is minus 1. This point has a, what's minus 1 times by 2?
Minus 2.
So that point goes to there. Okay, what's 0 times by 2?
0.
0, that doesn't move.
And that's 2.
Okay, now Hamza, this has a height of 1. And we're going to multiply that by 2, that gives us 2. Okay, so should we try drawing this one now?
Yeah.
Okay folks, a little bit wonky over there. So this is the graph of y is equal to... Okay folks, thank you very much for your patience today. I know it's been a bit of a long lesson, 3.5 hours in total. So you worked very hard and you got to the end of the paper, that's excellent. So I'm going to stop the video. Okay folks, we'll see you all next week.